There we have all sides and angles of a right-angled triangle labeled. Why are we labeling the sides and angles of this right-angled triangle? Our intention here is to show the relationships among the trig ratios of the angles of a right-angled triangle. Consequently, the relationship among the trig ratios of complementary angles. In a right-angled triangle, the two acute angles are complementary. They have a sum of 90 degrees, and for complementary angles, there is a relationship between the sine and cosine of those angles. Now, what we have here are the labels of the sides and angles. Sides are labeled by using common or lowercase letters. The angles are labeled by using uppercase or capital letters, and that is a convention in labeling sides and angles of a triangle that we adhere to quite often. For example, when we are presenting the sine and cosine rule. However, some mathematicians do not stick slavishly to that convention. First of all, if we are going to identify or state the trig ratios of any angle of a right-angled triangle, we need to label the sides relative to that angle. However, the hypotenuse is always the longest side and is opposite to the right angle. The hypotenuse, as we see, is opposite to the right angle, and it is the longest side. Also, the hypotenuse is not dependent on the position of any angle in the right-angled triangle. The hypotenuse is always, invariably, the longest side, and it is opposite to the largest angle, which is the right angle, as it will be in a right-angled triangle. The side that is facing the angle A is said to be opposite to the angle A. The opposite side of A, the side opposite to the angle A, is facing the angle A, which is opposite. That is the side opposite to angle A. The side that is beside the angle A is adjacent to the angle A. The side that is adjacent to A is beside the angle A. Also, the hypotenuse is adjacent to A. However, the hypotenuse is that longest side opposite to the right angle, and it has its special name. So when we are speaking about the adjacent or opposite side of an angle, the hypotenuse is never mentioned. So we are not speaking of the hypotenuse. It is that special side of the right angle triangle. Here are the trig ratios of A, and not only the trig ratios of A, but they are the trig ratios of all angles. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We are saying that it is sine A, cos A, tan A, but this is true for every angle in a right-angled triangle. If we need them to be specific to the angle A, then we will have to go inside of this right-angled triangle, and we need to take relative to A, the side opposite to A over the hypotenuse, the side adjacent to A over the hypotenuse, and the side opposite to A over the side adjacent to A. What we have here is generally true for all angles in a right-angled triangle, but to make it specifically for the angle A, we will have to use the side opposite to A over the hypotenuse. Substitute the sides of the triangle in their respective places in the trig ratios, and that will cause the trig ratios to belong to A. So let's go. For sine of A, the side must be opposite to A over the hypotenuse. For the cosine of A, the side must be adjacent to A over the hypotenuse, and we have those labeled already. And for tangent, the side opposite to A over the side adjacent to A. And there we have all three trig ratios of A. We are going to take a look at all of the trig ratios of the angle B, and we will use the triangle as it is. So we will maintain the labels of the sides and angles from the previous slide, which is the same thing that we have right there, and we will do our trig ratios relative to the angle B, which will be the trig ratios of B. In order for us to do that, then we must first identify the sides relative to the angle B. On this occasion, we will concentrate on the trig ratios of the angle B. Therefore, the sides will be labeled from the perspective of angle B. The hypotenuse is invariably the same. The hypotenuse does not change. It is the side opposite to the right angle, and it is the longest side of the right angled triangle. The side that is facing the angle B is said to be opposite to the angle B, just like this side which is facing angle A is opposite to the angle A. The side that is opposite to the angle B is the side that is facing B. On the other side of B, opposite. All of these are words that we use in everyday life, and they mean the same thing when we are taking a look at the sides relative to a particular angle. They have the same meaning. We have the side opposite to B, which is the side G. It is opposite to B. The side that is beside the angle B is said to be adjacent to the angle B. Which side is adjacent to the angle B? The one that is beside the angle B. Do not forget that the hypotenuse is also adjacent to B, but the hypotenuse is that special side, and we never say, for the intents and purposes of trig ratios, that the hypotenuse is adjacent or opposite to any other angle except the 90 degrees angle, which it is opposite to. Here are the trig ratios of B, and what we have representing the trig ratios of B are also the trig ratios of all angles in a right angled triangle. This is a general representation of the trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. In order to make these specifically for the angle B, then we will have to use the sides that are opposite and adjacent to the angle B. We know that the hypotenuse is always generally the longest side, which is opposite to the right angle. That does not change. Substitute the sides of the triangle in their respective places in the trig ratio. So for B, sine is opposite over hypotenuse, the opposite side of B to the hypotenuse. The side that is opposite to B over the hypotenuse, and that is sine of B. Cosine of B, the side that is adjacent to B over the hypotenuse. And for the tangent of B, the side that is opposite to B over the side that is adjacent to B. Opposite over adjacent, and that is the tangent. Now that we have all of the three trig ratios of the two angles, then we will pay attention to some facts and findings. The first one, as you can see, sine A is equal to F over H. Cos B is equal to F over H. So it is clear that sine A is equal to cos B. We see there that the sine of A is equal to the cos of B. Sine A is equal to cos B. And by now, you will see the other one, which is, no doubt, since we have seen that, the other one is going to be anticipated. Also, the cosine of A is equal to the sine of B. Cos A is G over H. Sine B is G over H. Cosine A is equal to sine B. Now, only for the tangent. Well, we imagine that we are going to take a look at that also. What do we notice? That the tangent of A is F over G. The tangent of B is G over F. The tangents of A and B are the reciprocal of each other. Therefore, the tangent of A is equal to 1 over the tangent of B, or the other way around. The tangent of B is equal to 1 over the tangent of A. They are reciprocals of each other. It is noteworthy that A and B are the two acute angles in a right-angled triangle. Because they are the two acute angles in a right-angled triangle, if we add them, what will be the sum? Let's go again. They are the two acute angles in a right-angled triangle. If we add them, the sum is 90 degrees. Any two angles that have a sum of 90 degrees are called complementary angles. They are complementary angles. They have a sum of 90 degrees. The easiest place to find complementary angles is in a right-angled triangle. The two acute angles in all right-angled triangles, they have a sum of 90 degrees. Therefore, the easiest place to find complementary angles is in a right-angled triangle. However, as you imagine, complementary angles are not limited to right-angled triangles. As long as they have a sum of 90 degrees, then their trig ratios will be related in the following way. And as long as they have the sum of 90 degrees, then they can be shown to belong to a right-angled triangle. Therefore, what we are talking about are the fact that A and B are complementary angles. They have a sum of 90 degrees. The ways in which their trig ratios are related are consistent with complementary angles. Not just for right-angled triangles, but in right-angled triangles is the most popular places that we see complementary angles. And if we have angles that are complementary, then they can be shown to be the two acute angles in a right-angled triangle. That is how the trig ratios of the sine and cosine, the sine, cosine, and tangent of complementary angles are related. Let's say that again. The sine of A is the cos of B. The cos of A is the sine of B. And the tangent of A is the reciprocal of the tangent of B. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.